Hi Year 12, today we're studying the new topic of binomial distributions and looking at the Bernoulli distribution. This is an Extension 1 mathematics topic. So a Bernoulli random variable is a discrete random variable used when there are just two outcomes, success and failure. A Bernoulli random variable is x equals 0 to 1, where 0 is failure and 1 equals success. So we have some examples. Which of the following are Bernoulli random variables? So turning up a tail when tossing a coin is yes, because we have the success of heads or tails. So you can either get a tail or you don't get a tail. The numbers rolled on a die is no, because we don't have a success of rolling a specific number on the dice. We just have rolling a number on the dice. And hitting a bullseye when throwing a dart. So that's yes, because we have the success of hitting a bullseye or the failure of not hitting a bullseye. So now we want to construct a discrete probability distribution table and a bar graph for rolling a 6 on a die. Is this a uniform probability distribution? So we want to draw up a table. And in our table, we want 3 columns and 2 rows. And so this is our x, and this is the probability of x equals x. And we either have failure or success. So the probability of rolling 6 successfully is 1 out of 6. So failure is 5 out of 6. We then want to draw up a bar graph to display this. So we just need a y and an x axis, and we're going up. Need an arrow on either end, and we'll just be going up by a sixth each time. So we'll have a sixth, a third, halfway. Okay, so this will be a sixth, a third, a half, 2/3, 5/6, and 1. And so the probability of, we have a 0 and we have 1. So the probability of failure is 5/6. Looks like that. The probability of rolling a 1 is just 1/6. Which looks like this. So then we want to state, is this a uniform probability distribution? And this is not a uniform probability distribution, as it does not, the probabilities of success and failure are not the same. Go. So now we're going to talk about Bernoulli distribution. So a Bernoulli distribution is a general probability distribution for a Bernoulli random variable using P as the probability of success. So the probability of failure will be Q, which equals 1 minus P. So for Bernoulli distribution, we have the probability of x equals the piecewise function of p for x equals 1 and 1 minus p for x equals 0. We call p a parameter. In statistics, a parameter is a constant that describes a feature of a distribution. So we want to write a Bernoulli probability distribution for each situation. So passing a test with a probability of a pass is 56%. So the success in this, the probability of 1, will equal 56%. And then the probability of 0 will equal 100% minus 56%, which equals 44%. So the probability of x equals x is the piecewise function of success, which is 56% for x equals 1, or 44% for x equals 0. For our next example, we want to write a Bernoulli probability distribution for flipping heads on a coin. So the probability of flipping a head is a half, so the success is a half, and the probability of not flipping a head, so failure, is also a half. So the probability of x equals x is the piecewise function of a half for x equals 1 and a half for x equals 0. Then we want to write a Bernoulli distribution for selecting a red ball at random from a bag containing 7 red and 8 blue balls. So the probability of success, so selecting a red ball, is 7 out of 15, and the probability of failure, so not selecting a red ball, is 8 out of 15. So the probability of x equals x is the piecewise function of 7 out of 15 for x equals 1 and 8 out of 15 for x equals 0. So then which of the distributions in part A are uniform probability distribution? The one that is tossing a coin, so that was flipping a heads on a coin slash flipping a head on a coin as the probabilities are equal. Now we want to talk about the mean. So the mean or expected value of a Bernoulli distribution is Ex equals P. So if we want to find the mean of each Bernoulli distribution, we have the probability of x equals 1 equals 4 out of 11, and so that equals our P. So therefore, our mean, which equals our expected value, is equal to 4 out of 11, as it equals P. For part B, we want to find the mean of this Bernoulli distribution. So the probability of x equals 1 is our 9 out of 10, which equals P. So therefore, our mean, which equals our EX, is equal to 9 out of 10, which is the same as our P. Then variance. So the variance of a Bernoulli distribution is var x equals P times 1 minus P in brackets. And we have our last example here, and we want to find the variance of each Bernoulli distribution. So the probability of x equals 1 is equal to P, which equals 0.6. And so our variance of x is P bracket 1 minus P. So that equals 0.6 bracket 1 minus 0.6. So that's 0.6 bracket 0.4. And what that equals is 0.24. For B, we want to find the variance of this Bernoulli distribution. So the probability of x equals 1 is equal to P, which equals 3 over 5. So our variance of x is P bracket 1 minus P, which equals 3 over 5, bracket 1 minus 3 over 5. So what this equals is 3 over 5, bracket 2 over 5, and it equals, when we multiply the two together, 6 over 25.